welcome back to another amazing episode of Containers on the Couch. I know it's going to be amazing because I have an amazing guest here today. My name is Meish. I'm first going to introduce. This is Mike. Mike, please introduce yourself. Tell us who you are.
Yeah, hi, Meish. Hi, everybody. Thanks for having me on a Containers from the Couch. My name is Mike Fiedler, at Mike Fiedler on Twitter or at Mike the Man on the Fediverse. I'm coming to you from New York City, an AWS container hero, and been working with AWS for well over a decade now and working on a variety of different technologies for 3 decades. So I feel like I've seen it all, which I hasn't even scratched the surface. There's so much more to see.
I think you have scratched a lot more than I scratched, but that's okay. But thank you for that introduction. My name is Meish. I'm a developer, Meish Silo Casing. I'm a developer advocate with the ECS service team. We do this pretty much a couple of times a month. Today we're here with Mike. And you mentioned something about being a AWS container hero. What is that? I'm not sure everybody on the stream might know what that is.
So the AWS Heroes program is a select program for individuals out in the world who are considered, have gone above and beyond in certain areas or get depth into certain technologies. Doesn't mean that I'm never allowed to step into like a Lambda world or a data world. It just means that I've spent a lot of time working on containers. And I think there's roughly about 250 heroes worldwide. We try to get together with different service teams and different calls to just kind of provide salient feedback from our experiences, as well as federate out the knowledge that we've acquired through blood, sweat, and tears out to the community.
That's nice. Okay. And as we say, it's a kind of an honorary title, which is awarded to these amazing individuals, which do provide amazing feedback and help to the rest of the community as well. And hey, Vlad, how you doing? It's good to see you as well as usual. And please, as we said, not too much heckling, only a tiny bit in the chat, they'll be okay. Today, we're going to be talking a tiny bit about container optimization. Firstly, why containers?
So why containers? The notion of containers, for the unfamiliar, are a great way to package up applications into a consistent artifact that can be run multiple times, instances of a container image. And if we go back on the evolution of computing, right? We used to build out hardware servers, so you would have to buy a bunch of servers, get 6 to 8 weeks lead time, rack and stack them in your data center, provision them, and manage their life cycle for 5 years. And that came at a hefty cost. Then we started with cloud computing, where we shifted the majority of that workload to AWS EC2, which was, again, just giving us a piece of hardware in a data center somewhere that I didn't have to rack and stack and I could get at the end of an API call. The evolution of containers goes back way long ago to like, how do we slice up the Linux kernel into discrete namespaces, and how do we run, secured slices of particular applications in a more isolated fashion while sharing some of the underlying compute resources. And that gave us a couple advantages where we could better leverage hardware. So instead of running a server at only 10% capacity, we could run a server closer to 60, 70, 80, 90% capacity, running many, many instances of applications in containers. And we've gone to evolve that to now specific container orchestration platforms such as ECS and EKS or Kubernetes to basically give you the power to not have to worry as much about the underlying compute as you may have had to before, but then you kind of worry about a level up, a higher level of abstraction, where I can confidently get the same application, the same bytes that I coded and packaged once, running all the time. I can just keep relaunching new containers from the same image. AWS EC2 did this with AMIs, so you could get a sealed AMI, but the time to get one of those was measured in minutes, whereas containers is measured in seconds.
Yeah, and I'm extremely, extremely relieved and happy that you said AMIs and not AMIs, because that's a tiny bit of a pet peeve some of us have. But Whatever you want to call it, it's still good. It does the same thing. So optimizing containers. What are the aspects that we have to look out for when you start optimizing containers? I think you pretty much should have like a kind of a bucket list. And Jess, good to see you as well. And anybody else would like to chime in through the chat, please. We would love to hear your questions and comments, so please feel free. So going back to my question, sorry about that, was what are the things we have to take into account when we want to optimize a container?
Yeah, so I think when it comes down to any kind of compute artifact, you always want to be cognizant of the time it takes to launch, right? And that's true of any service. It could be an EC2. Again, you want to be cognizant of how many things you put into the AMI versus the EC2 init. Like, what do you want to do when the instance starts up? Because when you're dealing with scaling strategies, you want things to scale as fast as possible. Because if you're getting an influx of traffic that's unpredictable, or this is just normal prediction, you do want these elements to be ready as soon as possible. Because with a lot of container orchestrators, you do get billed by second or minute, depending on which services you're using. So the faster they're available for a end user to use, the faster they will get responses, the lower latencies you'll see across the board. And then, you get an overall better experience. There's also another element of optimization, which is cost, right? So I mentioned that, you pay per utilization. So if it takes, 10 seconds to start up a container, you're paying for those 10 seconds, as opposed to if it takes 5 seconds, you're paying 50% less. And then also on the cost comes down to storage, right? Every container image is measured in bytes, right? Like, we build applications, we stuff a whole lot of files into a container image, and then we have to store those bytes. And storage will add a bit of cost. Obviously, if you're using something like ECR or S3, the cost is low, but again, it can stack up. So the fewer bytes you have, the less you have to pay. And all of those are different optimization strategies that I tend to think about, of how fast do I want to go? How fast do I want to start it up? And a lot of these are, relatively easy fixes, but that we're going to go through and show a few different strategies to kind of accommodate those different parts. I think I lost one other cost driver, which would be transfer costs, which, if I have a large container image, I have to transfer that and start it. So the fewer bytes you have to transfer, the fewer bytes you have to pay for.
Correct. Of course, there's different cost methods or cost strategies between where you're pulling it from, if it's in the cloud, from out of the cloud, across clouds. Those are all kinds of things you have to take into account. So what kind of tools can we use to get into this?
Yeah, so let's share a terminal screen here that I've got prepared with some container optimizations, and I put together a Python app in this directory where I basically have two files. I have an app.py and a Docker file, which use the definition for my container images. If we were to look at the app.py, it's a contrived example, but I wanted something that was a little bit more than just a hello world. I wanted to import two popular data science or scientific libraries, NumPy and Pandas, both of which weigh a certain amount. Like, they're not lightweight libraries. I'm not doing a full C extension compilation example here. We can delve into that another session. But basically, I'm importing a couple libraries, and when I run, I print out a few things. And if we were to look at the Docker file, well, I start out with a base so there's a base image. I run my pip install for my external requirements. I copy, I set my working directory to where it is, and then my startup command, right? So in a general situation, I would do a Docker build, right? Give it a name, example Python, and just go ahead and build it, right? So this is going to download the base image, which I have already pre-downloaded here. It runs all my cached, I've run this build before. But if I were to look at the image, example Python, I can see it weighs in at 1.11 gigabytes, right?
Okay.
So
it's not a small image.
I'm sorry?
It's not a small image.
That's not a small image, right? But it includes pretty much the entire base image of Python 3.11. My code, which, if you remember, was 400 bytes, 405 bytes. And those two external dependencies, pandas and NumPy, and anything that they rely on.
Yeah.
Right. So I'm getting this like image that is what, this will launch, right? It might take a few seconds to transfer 1 gigabyte across the wire when I launch, right? I can run the container that I built, right? Just to prove that it works, right? Example Python, and I use --rm, so that way the intermediate container gets removed because I don't need that container once it's completed. All of this data is coming from the installed libraries. Yeah. So the first thing that I can do when I deal with this kind of Docker file is a tool called hadolint, Hadolint. It's a great tool, and Mesh, if you wouldn't mind popping up a URL to that one.
Yeah, I'll find it quickly while we go.
Yeah, sorry. But I can pass it the Docker file. I've previously installed it. I'm on a Mac, so you can brew install, but if you're on another platform or don't want to install it, the hadolint docs show you how to use Docker to run hadolint to inspect your Docker file, which is kind of meta if you think about it. But what it is, it's a general linter. Right, and we love linters because they tell us early on in the life cycle what to do, and there's also a bunch of rules on the hadolint website. So the rules here that I'm getting warnings for are DL3013, where it's telling me to pin versions in pip. Which again, like if I was using a real production application, I would absolutely do that. I wouldn't just pip install here. Let's cat that Docker file so it's in our. I wouldn't just pip install. I might use a tool like a requirements.txt file that has all the which again, that's kind of what hadolint is saying. You should probably do that instead of do this. So that's just a good warning on safety and like reproducible builds. Because right now, if I run this build, I'm going to get the latest version of NumPy and pandas, as opposed to I knew what I got when I built it. But the more interesting one that I want to dig into is this one, 3042. Avoid use of a cache directory with pip. Use pip install no cache dir. So if I were to take that suggestion and add that no cache dir right here and run my build again, let's give it a name, no cache. Oops. I have to run it instead of build it. So I need to build and give it a label, right? No cache. So that way I can show these side by side. Now, because I've changed that, it's going out and saying, all right, I'm not going to store the pip cache inside the image. So we should save some bytes on the resulting layer. So I had my Docker image ls, and we can see I've saved, not an enormous amount, but I've saved about 30 meg.
30
roughly.
megabytes,
Yeah. Right. So I can see the no cache version is right there. So hadolint is one of those tools that, is very useful if I were to have items that were, more platform oriented. So, apt get update, and then apt get install. Oops. I don't know, something like git, right? If I needed git. The hadolint warnings for that one gives us some more. Delete the apt-get lists after installing something, right?
Okay.
So hadolint detects a lot of these different warnings and is just generally good guidance to say, here's what you ought to do in order to avoid bloating your image by having these leftovers that aren't useful during runtime, right? I only needed it in order to install the packages. Just same thing with the pip cache.
Yeah, that's an awesome tip.
Yeah, so hadolint, it's a great tool in the toolbox to have kind of around when you need it. And let's take another look at different optimization strategies. So I have a second app here, which is a Node.js app, and very similar, right? I gave myself a README here, but if I were to look at the package.json, which is very common in Node.js, I literally lifted this example out of the Node.js documentation to say, here's how to use Docker files. So it's like, there's nothing magic here. We start a server called server.js, and we have an express dependency, which is a web server. And then if I were to check out the server.js, it imports the express, it sets some ports, and then sets up some stuff.
Hello world and unblock,
Yeah. Really straightforward app. And if I were to build this one, right? So let's give that example, Node.js, and say, just build this as is. Cool. Whoops, I have a problem in my file. That's right. So if you have a package.lock, then that's what CI will work. I've never installed that on this machine, so I don't have a package lock. So again, this is just an example. In reality, you would install your dependencies, lock them, and include that lock file, and then use that npm CI, right?
For pinning those specific versions in order to get the use of the reproducible builds.
Exactly. And let's take a look at this image size. So this image is a much more reasonable 124 megabytes, right?
Yeah.
But what's in there, right? I basically installed one package, right? So what's in that? We can use different variants from the from. So if I were to look at that Docker file, I'm using Node 16 Alpine. Right? Whoops, I should not. That's the wrong example. Let's rebuild it without that modification.
Understood. Okay.
There we go. That's what it was. It was again 917 megabytes. Right. That's the real size.
That's the default Docker image with Node.js inside.
Node.js 16, which again, this is very similar to the Python version, which is 1 gig, right? So these are like hefty images, the base image, which have a lot inside of them. So if I were to do Docker run example Node.js, just do like a bash command. Oops. Well, it's exiting because the command is like, all right, well, I exited. I forgot to add a interactive mode. There we go. Right. So here I am. I might have a GCC. I don't have GCC, but I have other tools here in like user bin. Like this has a Python, right? Version 2.
Node.js machine.
It has on a Node.js. Like why do I have Python 3.7? Like why do I have all this? And that's because the base image in the Docker file, the Node 16, it comes pre-built with a whole wide variety of tools, kind of like that whole like battery included kind of thing. So you don't have to like install everything, but if I want to, I can. A lot of these base images, Python, Node, very popular ones, Golang, they have a slim variant, which basically excludes a whole lot of the extra things, right? So I can build it again, and if I were to look at it now, it's 186. So we've dropped.
That's a big difference,
right? And it includes, yes, Startup Builder. It does include NPM because we were just able to run NPM install. So
Yeah.
like the base tools are there for Node.js. You can see all of the different parts that are included in the base image, usually on kind of the ECR gallery or the Docker Hub webpage for that image. So far, the Alpine variant is another one. So these base images are based on a Debian variant. So Debian Bullseye or Buster, and they have a Slim. And Alpine Linux is an even smaller kernel, where that's where we can get this particular image all the way down to 124 megabytes, which is a far cry from 900 megabytes.
For sure.
Now, obviously, you want to test all of these things on IT, example Node.js. So there we go. It's running on that version. And if I were to curl vhep localhost port 880. All right. Well, I didn't expose the port correctly.
Okay, so, but that you get, in other words, you would get the hello world and whatever we say from running on hostname, like we defined in the actual Dockerfile itself.
I killed it off because the server, but I think this gives us a nice visibility into what what variants can do for the different size. Yeah. So let's take a look at the Docker file again. Let's turn it back to the default.
Okay.
And try and understand what those, let's rebuild the image so that way we have it. If I would have given those specific tags, I wouldn't have to rebuild this image every single time. So I could have said this is like default, right? And then I've got
the other one would have been Alpine or Slim, whatever it may be.
Exactly. So I can give those different names and tags, so that way I can, when I'm doing an image ls, I can compare and contrast, which I didn't do, but I could have and probably should do. But if this is the default, yeah, we'll do it on the next one, right? But if this is the default and I want to see what's in here, right? So right now, I'm a little restricted as to kind of what I can inspect, right? It tells me Docker inspect, it gives me this big JSON blob, which, all right, well, here's these different configurations and author, config, all this other stuff.
A lot of metadata, which doesn't really tell me that much, I can see.
Right. But it does start to get into like all of these other different like layers and diffs, which again are somewhat opaque. And like there are ways to get at this data and say, hey, Docker, show me what's in this layer. But instead of going deeply into that, into like trying to understand all of those, there's this really cool tool called Dive. And Dive, which I thought I gave you a link to, but I didn't.
I will find it. I got it as well. Yeah.
Yep. Dive is a really nice tool to help kind of dig into the container image, right? So with our we want to give it a actual tag. So what this is doing is it's looking at my current Docker Dive. If you don't have an image, it can build the image for you if the Docker file is in the local directory.
Okay.
So it can build it, and then, but like I already have an image. So it's fetching, it's analyzing, it's building a cache of what it sees, and we can navigate every single layer of what's in here.
Nice.
Like my starting point for this image is all the way down here where I set a worker, I copy, I run. So there's some existing image layers that I get from the upstream node image that I can see. They do an apt update, they do an install. So you can see a lot of this information from like a Docker image history. So for instance, Docker image history of the same image. And I can see some of this, right? Where all of these are pretty much not mine, and then these are mine, right?
Okay.
And they go in reverse order. So this is the last command in my Docker file. This is the one above it, and so on and so forth.
Yeah.
But it's not really easy to like really navigate these. Obviously, there's flags to like expand what each column is so I can get the full contents. But when looking at layers, I can see that when I do my npm install, I've added 6.3 megabytes, right?
Yeah.
I can, try to determine what is added at each level of these, hundreds of megabytes. But let's say I want to see, okay, only what I want. Using keyboard, I can tab back and forth between the two panes. And one aspect I liked here, which you can't see it on the screen now because the screen is a little small, but if I hit Control U, it'll only show me files that are modified in this layer step, right?
Okay.
So we can see here that npm install is also doing a cache, right?
Yes.
So I can use space to kind of like drop these down
okay.
and start to kind of analyze where the space is used. I think I might need to expand this window a bit to get some, there we go, get some file sizes in.
Okay.
So as with anything, they'll roll up, and I can see that the majority of my 6.3 megabytes is
Came
cache.
from npm cache. Exactly.
Yeah. So if there's a flag that I can add to my npm install or npm in production or node in production do not cache, I can slim another 4 megabytes down, leaving my my impact to this layer to only 2 megabytes. Right. So if we use the really small Alpine example of 124 megabytes, I could slim that down to like 120 megabytes. So I could get even smaller.
But and when we're talking with the 122 megabytes is a lot less of a problem when we're talking about sizing between, as you said, 986 to 124, which is a much bigger difference.
Yeah. And again, like at some point, every bit counts. There's other views in this view over here on which again, in a larger screen, I don't remember exactly how to resize everything, but you can see Dive will report this file has been overwritten 5 times. There are 5 instances in every layer. So that's using about 4 megs, and repeat files or files being overwritten during builds is another signal of maybe we're overwriting a file too often. Like that just contributes to bloat, because in Docker image or container image layers, each layer is immutable. So even if I create one layer that says write a file or install a package, and then another layer that says uninstall that same package or delete that file, that the results won't be available, but I'm carrying the disk cost, right? That doesn't disappear from the layers. There's other strategies around squashing layers, which is a bit of an advanced technique, which I can almost argue that most of the time you should try to not squash layers, because that impacts your ability to cache those layers. So why do I care about layer caching? Well, in these layers that we're showing over here, these top ones are likely to never change for the life cycle of my container image, because I'm pulling them from a base image. So no matter how many times I change my application, those layers are not going to change. So I can benefit from build time caching because I'm just reusing the same layers. And I can benefit from runtime caching because as the application changes, if that image was previously on the runtime host, it only needs to download the delta. Those deltas are very applicable when you're running ECS on EC2 or EKS on EC2, where Fargate is going to not have as many opportunities to cache because it's going to launch a fresh instance. So
and pull down the whole image.
and
Exactly.
pull down the whole image. So having that distinction or being aware of those different gotchas of here are some things that you can do to speed up is by removing layers or leveraging layering strategies when you're on the different compute times, runtimes, then can accelerate your image startup time. Because again, there are fewer bytes to traverse over the wire.
Yeah. And I would like to just welcome those viewers that have just joined us. We're talking today about container optimization with Mike Fiedler. My name is Meish again. If you have any questions, please drop them in the chat. And after I've said that, okay, so we've made our images as small and we say lean and mean as possible. What else can we do to optimize?
So let's take this image specifically. Let's bring back our Alpine, right?
Okay.
Let's build that and call it the right name this time.
Yeah.
Right. There we go. Simple node. There we go. So now we're down to 124. If we were to dive into that one as well, it's going to take a second, but there we go. We can see that the base image is, again, like very lightweight. They've only added about 120, and then again,
17. Yeah.
117.
Yeah,
rounding. And then my impact is here. And then again, we can inspect what each layer adds. So for instance, this is showing that it's adding a bunch of base things. Looks like their base image even adds like 1.6K of NPM logs. Maybe that's something to like look at the upstream and say, maybe ignore.
You can remove that, yeah.
Remove that. So there's opportunities to like investigate and help the upstream to say, you know what, there's opportunities here to remove things that you don't necessarily need, right? The base node modules that you get are 11 megs, but like maybe there's certain flags during the installation where we don't care about the documentation or man pages and save a few more bytes here and there.
Yep.
Right. Hey. What else can we do? So this particular image seems to be pretty lean and mean at this point. Let's try another container architecture. So in the two examples that we've shown so far, Python and Node, both of those examples are using application runtimes that are somewhat dynamically interpreted, right? So it's not a compiled language where, you know, if I was writing in C or Rust or Golang, I can compile an artifact and then run the artifact. If the analogy stands true, our container image is kind of the compiled artifact, right? So we're compiling a container image, which is kind of that bundled image. However, you know, other language runtimes might have a different approach, such as Go. So let's take a look at Go.
So while you're diving down into the direct, there was a question from R2D2. Are you using Finch? So firstly, let me just explain what Finch is. Finch is a open source project which we released for, I think, at reInvent 2022, a couple of months ago, where you can, it's a drop-in replacement, almost a drop-in replacement for your Docker tooling. Instead of paying for a Docker desktop, we provided an open source tool called Finch, which has pretty much parity, almost one-to-one with using what is the regular Docker desktop applications. So are you using Finch?
I am not using Finch yet. Last time I took a look at Finch, it was a little early in beta for me. And I figured for this demo, I'd use something that I'm a little more familiar with, which is Docker Desktop, that I use for a lot of open source projects. Finch is promising. I'm looking forward to it evolving and becoming a little bit more, you know, battle tested, if you will, which means I should absolutely go back and test it out and find some bugs and report them fix them, and that's great.
And
there's
that's part of
also,
our team as well. So definitely, we would love to hear your feedback based
yeah.
on whatever you can find for sure.
Yeah, I think there's there's always going to be an interesting balance between the runtime that you use and the underlying compute resources. If you're running on a on a Linux machine, then you're going to be able to like use Docker natively or Finch natively.
Exactly.
But where it comes to like performance characteristics, this is where Docker Desktop has kind of sunk a lot of effort into making the runtime faster, but Containerd has been kind of beating everybody at the performance. So it looks like Docker Desktop might be incorporating Containerd, and so it's great to kind of see all of the different technologies kind of help each other get faster and better. I think Finch has a promising future, and I'll have to double check after
and
this
the
call.
link for that, of course, is on the screen. So please have a look at the tool after the session over here today. Don't take your eyes off Mike, because it's going to be you're going to miss a lot of stuff.
Don't leave us. Finch should be cool, and hopefully we'll get there. But
I stopped your trail of thought. Sorry.
Yeah, train of thought. So we spoke a little bit about the Docker layers that you get within a given image, right? And how those layers can have impact on the resulting size. And with the dynamic runtimes, you need the packages, the dependencies to come along with you for the ride, right? Like
Correct.
If I need NumPy, I need to pip install it or get it on disk. And then, I might not need pip anymore. So in theory, I could like pip uninstall pip, which that's a
it's like shooting you, what we call stun. It shoots you out the node in the head or shoot yourself in the head. But that's an old, long time traditional architecture thing, but that's okay.
Yeah, it's like it's valid, right? But the example that I'm going to show is I have a simple Golang app, which again, going on the theme, is like, all right, let's print hello world, right? It's a command line argument. Very, very straightforward. I literally copy pasted this from somewhere else, right? Where it's not a complex example, but when it comes to dealing with a compiled language, there's steps involved, such as a Docker file where I have my base image, Golang. I set my working directory. I copy everything. I'll go mod download. That's to install that like CLI dependency. Go build the main from here. And the command is, I'm in working at main, and the command will be main, right?
Okay.
So Docker build, let's give it a tag, example, Golang default. So this one I haven't built recently, so we're going to see some of those Docker pull and contexts. This is more close to the real deal. Downloaded in 0.7 seconds. It's running the build. The build takes 5.7 seconds, and we have an example.
And we're doing it live. Exactly.
And we're doing it live. All right. So that one, again, very similar to some of the other sizing, is somewhat bloated. It feels heavy for command line argument. One application that does one very, very simple thing. And if I were to Docker run this example, typo, example Golang default, bash. I think I have the arguments out of order there. Interactive mode. Right, main, at some human size, main is 4 megabytes.
Okay.
And if I were to run it, it does exactly what I wanted it to do. So it's 4 megabytes, out of 850, like that's huge, right?
Exactly.
Like, why do I need something that big? So let's, we'll also see that we have some other files in here, like multistage, right? Docker file. So one thing that we haven't touched on is the ability to exclude files. So I can create a dockerignore file, very similar to other git ignores that you don't want to include in Git, or just .ignore, which if you're using tools like the Silver Searcher or ACK, you can use those to control what you want to ignore. But in here, I'm just going to say, don't include Docker files.
Okay.
And then when I build that image, right, all of those layers are no longer, most of those layers are no longer cached, so I have to run the build. But when I run this, I'll see, okay, the dockerignore was included, but only the files that I needed.
There. Exactly.
Right. So that's another way to exclude artifacts from the resulting image to control. Maybe maybe you have a Node.js application that or a web app that does a pre-compilation into a dist folder, right?
Yeah.
And when I'm developing, I don't want that dist folder to get into the Docker container that I'm the container image that I'm building. I want the image itself to build it. Maybe there's a difference in architecture. Maybe I have like some dev flags that are included in there. So it's a really good way to kind of keep the junk out. There is a pattern that I've seen in dockerignore where instead of excluding, you exclude everything
and include the specific ones you want.
A specific thing. I think it's double star. And then, go dot mod, go dot sum. I think this is the right syntax. Let's give it a shot.
Right.
There we go. And there we go. So this means I'm being very explicit about what is allowed to get into the Docker image, which might be, cumbersome. You could use wildcards, you could use directories, but it means that no file goes into this image that I did not explicitly allow. So kind of an allow list versus a block list. So both strategies are valid. But for us in this Docker image for this Golang app, we're still looking at the size. It's still 835 meg. So I could, do the whole tricks that we did with, use an Alpine image, right? Let's see what that gives us. I have a sense that this will still be bigger than the 4 megabytes we actually need.
But I hope it won't be the 835. The suspense.
Build. The build time took a little bit longer on this one, 7.3 seconds versus 5.6. So that's interesting.
I assume it didn't have all the dependencies decided that they need to pull something else down. Could be.
Possible. But we're down to 300 megs.
Wow. Okay.
So that's a big difference, but still significantly more than my 4 megabyte that I actually need for my runtime.
Yeah.
So this optimization strategy is also known as the multistage build. So where we have a notion in our or syntax in our Docker file where we say as. So we're giving this a semantic name, saying this builder, you're going to go all the way down till the next from, right? But now we have a relevance. So all of these are the same as we did before. And then Scratch is basically a placeholder in Docker images to say there's nothing here. Like just don't put anything there, right? And then we copy from builder from here app main. So we know we've built the app main to my current app main, and we keep the command. And
Okay.
let's take a look at those side by side, just so that way it's a little more clear as to what the differences are. All right, ignore the Alpine that I added just right now, but we added an as builder, and then we basically finish this, builder stage. We don't care about that image once we're done, right?
Yeah.
We're only copying this 4 megabytes. So let's go ahead and build that one. So because we have a different file, it's not just Docker file, we have to specify with -f which Docker file I want. Still have to give it my tag, which is example Golang multistage, and context is here. All right, that was pretty fast.
Yeah.
I've done this one before. And now we can see when we look at the image size, that's now 4 megabytes, 4.5 megabytes.
Wow. And this will work pretty much on any kind of language, or like you said, for specific runtime, like if I would have done this also on the Python or the Node.js, would have also made it so small?
So the multi-stage will only work for environments where the dependencies, the installation dependencies, are no longer necessary for the runtime. So for example, if in my Python image, if I was pip installing pandas and PyTest, right? I don't necessarily need PyTest for my runtime because that's a testing framework. So I could use a multi-stage approach to say I only need the Python runtime, I need the pandas packages, and only bring those over. But it won't be as small as 4 megabytes because the Python runtime is about 20 megabytes or however large it is today, right? So the multi-stage build is a really good way to take artifacts like this and say, I'm going to build a stage that's my builder stage that installs dependencies. I'm going to build a production stage that has only the configuration files or additives. From the builder phase, I'm going to build from the prod image, I'm going to build a tester image that will also now include my test images or packages. So that way I can build the production artifact, build a test image from that, run tests against the test image to certify that the production artifact that I built is good enough. So this allows me to prevent polluting my production artifact with test data. It's all about kind of maximizing your space. Most non-compiled runtimes won't get down to this size because with Golang, with Rust, with C, you are compiling down, and specifically with Golang, I'm including the dependencies into the compiled artifact.
Yep.
And it works, right? Like Docker run.
Definitely does.
RM. They all work the same way, and will all kind of execute. So like no matter what I do, it's all still running the same code. It's just how many bytes have I wasted getting that code to where it needs to be.
Exactly.
So
that's really nice.
for this kind of example, I definitely want to use something like a multi-stage.
I remember we had a whole list of things on our schedule for the content. And as I see, we only have another 11 minutes to go. And I have to be very, very cautious of the time which we actually take from you as well, and from the next show, which is coming up afterwards, I think, as well. So I think we'll have time for one more topic. So I'm going to give you the honors to choose what you would like to go over.
Sure. Yeah. I think when it comes to container speed and container image speed, we've covered a lot around images and the image sizing. I think a really good one to call out is only running a single essential process in your container. So in this case, I'm running command line or a web server. It's very common to like take a web server and front it with something like an Nginx or another kind of web server alongside, or have a sidecar. And it can be very tempting to add like a process manager inside of your container. So if I was looking at system D or V6. So the ability to kind of only run one process per container helps with system and resource isolation. It helps with like logging, so that way your logs aren't mixed together. Because if I'm logging from two different services in the same container, they're just going to show up, and it'll be harder to kind of separate those in whatever observability that I'm trying to find. It's also harder to kind of isolate resource consumption. If I'm running two processes, which one's using more memory from my external observability? So run one process per container. I did a deep dive into this about 1.5 years ago around like the speed of communication between containers, which tries to get empirical around like, is it worth it? And the answer was no, it's not. The container runtime layer gets into that. So Mesh will hopefully share that blog.
And that was the container to container communication. Then just pressing the right thing. Yeah, perfect. Yep. So this is the link for it, and I'll put it here on the screen as well.
Yep.
So while that comes on the screen, there were a couple of questions which came up from the chat. So the first one was from Envious Ferenzi. I apologize if I'm butchering people's names, but I hope I did it okay. Are the multi-staging is multi-staging removing or adding security patches? I think I know the answer to that, but I'm going to give you the honors.
So the simple answer is it's not removing or adding anything that you haven't added, right? So if this base image has some security vulnerabilities, if the resulting image won't have those vulnerabilities unless they impact the compilation. So if there's a vulnerability that says when I go build, that's a problem, that would still be contained in there, and you'd want to update your base image. But if there's a dependency in this one, and this is my resulting image, if I were to run that through ECR scanning, those vulnerabilities should not show up because they're not in the resulting final image.
Exactly. So I hope that answered the question. There was another one which I will get to in a second, but this is what the other one I want is multi-stage running on top of Scratch. Is Scratch deployable to a prod environment? What do you see by these common use cases? So from what I see, it is running from Scratch, correct?
Yep. So the multi-stage is on top of Scratch, which gives us that ability to not have anything that we haven't put there, right? Is it deployable to prod? Yeah, I mean, that's up to you, right? Are you comfortable deploying this resulting 4 megabyte image? I would, right? Like that's how I would go about doing it.
Yeah.
And that just helps kind of alleviate a lot of other concerns of there's nothing else in there, right?
Yeah. And the last question, which I'll answer, and that was, are there any other blogs that cover the rest? So of course, we're going to be putting all the links from the show today. They'll be in the show notes, either on YouTube or on Twitch. You'll be able to find all the links that we're going to be talking about, and whatever else we didn't get to today, we'll also paste the links there with some information about them as well. So we got you covered, the Tech Guy 21. So I hope that helps as well.
Yeah, absolutely. And all of these examples, we'll also throw those up on GitHub, so that way you can play with them with a couple READMEs that describe the different tools, some other links, just so that way you can be aware of those.
Perfect. So I know we're going to finish a couple of minutes early, but I would like to give the people after us a bit of peace of mind that I don't have to bite their nails to see that we're going to finish on time. So firstly, I would like to thank you very, very much for your time. It has been extremely informative, amazing knowledge that you shared here with everybody here today. If somebody would like to reach out to you, how can they get in touch with you if you would like to let your details or any kind of way they can get hold of you?
Yeah, so I'm at Mike Fiedler on Twitter, which that's an easy way to find me. I'm at Mike the Man on the Hachyderm Mastodon service. And my blogs, miketheman.net, have a lot of different content there, and I'm pretty easy to find on the internet. I've got a bunch of different Slacks. I'm on the Hang Up Slack. Feel free to reach out. I love talking about different ways to speed things up.
Thank you very much, Mike. And my name is Mesh Silokasing. You can get hold of me on Twitter as well. I don't do Mastodon too much because I have a bit of a attention span problem jumping between 2 different platforms. That's why I also don't do Facebook either. So ping me on Twitter if you want to get hold of me. The resources and the recording, of course, will be available either on Twitch after the show and, of course, on our YouTube channel, which is containerizedfromthecouch.com. Please hit the subscribe button. Subscribe to our Twitch. It's not only our show. There's a number of amazing shows you can watch on a regular basis through the Twitch channel. And Mike, thank you so much for joining us today. It was amazing. And have a great day.
Thanks so much. Bye, everyone.
Bye.